I'm really excited to announce that from January 2023, I'll be able to further support you with small group tutoring, intensive revision courses in the holidays, or online tutoring too. So if you find the way that I describe things useful and you'd like some extra help, then please get in touch via my website, www.cardiff-maths-tutor.co.uk. Also, if you could hit the subscribe button, that would really help me continue to make these free videos. Thank you. Today I will be going through the November 2019 Mathematics Non-Calculator Intermediate Tier paper. Okay, so second page will always be the formula list. In intermediate we're only given two formulas, so area of a trapezium and volume of a prism. So they may come in useful, but they may not. Okay, the first question says, complete each row of the table. The first row is being completed for you. So the temperature at 10, it then went down by 4 degrees, so the temperature at 6 PM was minus 2 degrees. Internationally it's minus 3 and it goes down 1. So if we're going down 1, we're going further down, so we'll be on minus 4 degrees C. In this place here, we are then going from minus 4, going to minus 1. Now, if at any point you're there thinking, oh, I'm really not sure what to do, a number line could be a really, really good, useful thing to help you. So 0 would obviously be the number line. We're going from minus 4, so that would be minus 1, minus 2, minus 3, minus 4. And then we know we get to 1, so I've actually moved up 1, 2, 3 places, so that's actually gone up by 3 degrees C. And this one here, we ended up on 3, but that's from coming up, so it must have been colder because it's gone up to 3. So if I look where 3 is, 1, 2, and 3, to be up 4 degrees, then I must have been down 4 early in the morning. So 1, 2, 3 back to 0, and 4 would be minus 1 degrees C. Okay. The next question says, write 7%, 3/5, and 0.3 in ascending order. Okay. Now ascending order, think of a mountain. So there's my mountain there, snow on the top, little flag on the top. A posh word for going up the mountain is to ascend, and a posh word for going down the mountain is descend, okay? So descend is going down, ascend is going up. So we want the smallest to the biggest, okay? And they've told us that in the question just off screen here as well. Smallest to the greatest value. Now the best way to do this is to get them all into the same thing, okay? Now for me that's percentages. I like turning things into percentages, then I can just compare the numbers, okay? So what I'm going to do is I'm going to keep 7% as 7%. I'm going to change 3 out of 5 into something out of 100. So how many 5s go into 100? And the answer to that is 20. Whatever I do to the bottom, I'm going to do to the top. And then 3 times 20 would be 60. So that would be equal or equivalent to 60%. Okay. Now from here, we have then got the 0.3. So how do I change a decimal into a percentage? And the definition to change a decimal into a percentage is to times by 100, okay? To change a percentage into a decimal, you divide by 100 because that's what percentage means. It means divided by 100, so to work the other way around, I would times by 100. 0.3 times by 100 would be 30%, okay? So now I want to do the smallest to the biggest, so that would be 7%, then 30%, and then 60%. And what I'm going to do now is just change them back to what they originally were. Now 7% was 7%, 30% was 0.3, and 60% was 3/5. So I'm just going to write it in like that. Okay. Let's have a look at the next one then. Okay, number 3. It says calculate the value of 3x plus 4y when x is equal to minus 6 and y is equal to 5. Now the best way to do this for me is just to change this to open brackets for both letters. We're then told the value of x, which was here, so that's going to go there, is minus 6. So that's where minus 6 is going to go. And then y, which is here, so that's the second bracket, is 5. So 5 is going to go in that bracket. So I'm going to have minus 6 go in there, 5 go in there. 3 lots of minus 6. Well, something that I always write just by the side of my working to help me if I'm unsure is that if the signs are the same, we get a positive answer. But if the signs are different, we get a negative answer. i.e. if we have a 3, a positive, times by a negative, the answer is going to be negative. So we're going to have negative 18. 3 times 6 is 18, only 1 minus. Plus, and then it's just 4 times 5. 4 times 5 would be plus 20. Now, I can think of this as a slightly different way. If I think of minus 18, then add 20, I can actually think of it as the other way around. 20 take away 18, which is about a million times easier. However, if I was stuck and I was thinking, oh, I don't know if I can do that or not, again, think of your number line. That's already come up. 0 being there, minus 18 being down here. If I'm to add 20, if I add 18, I get back to 0, and then add 2 would put me on 2 there. So the answer is positive 2. Simplify the expression 9g minus 4f minus 3g minus 5f. Well, what we're going to do is focus on just the g's to begin with, including the sign in front. That's where people commonly go wrong with this question. They forget that that minus sign belongs to the 3g. 9g would just be positive 9g, take away 3g would give me 6g. Now this seems to be coming up an awful lot in this paper. We then have minus 4f, and then we want to take away another 5f. Now some people say, oh, 2 minuses make a positive. And that's true when you're multiplying them, but certainly not when you're taking them away. Again, think of your number line. There's 0. I'm on minus 4f, and I'm taking away, minus 4f, sorry, and I'm taking away 5. I'm going to go down a further 5 places to end on minus 9. So it's going to be 6g minus 9f. The next one says solve the equation 3m minus 7 equals 8. The way that I teach this is that I put an arrow down underneath the equals, and I try and keep the equals in a lovely straight line, and I want to get the m by itself. The best way to do that is to get rid of anything not physically attached to it first of all, because that's a lot easier than having to deal with dividing every single bit by 3. So what I'm going to do is add 7 to both sides. Add 7, add 7. So we get 3m equals 15. Well, that's 3m. I want to know what just m is, so I'm going to divide by that 3 that is timesing by the m. So I'm going to get m equals 5. I can always check to see if that's right by substituting that 5 back in here. So doing 3 times 5, take away 7. 3 times 5 is 15. 15 take away 7 is 8. That's what we should have had, so I know I'm right. This question here, which asks me to expand, means that 4 is going to times by both of these things here. So I'm going to get 4 times by 3x, 12x, minus 4 times by 5, so minus 20. Okay, next page, let's have a little look at this question here. Okay then, it says the mean of these two numbers is 7, and the range of these two numbers is 8. What are the two numbers? So straight into it, no messing around. Now, if I'm told that the mean of two numbers is 7, I know that a number, so question mark, add another number, and then divided by 2 equals 7. That's what that's telling me. The mean of two numbers is 7. When you add them together and divide by how many numbers there are, there's 7. Well, that means that the two numbers must add up to 14, because 14 divided by 2 is 7. I now need to think of two numbers that add together to give 14, and there's loads of numbers that do that. 14 add 0 would do it, 13 add 1 would do it, and so on. But the most important bit here to read is that the range of the two numbers is 8. So that means the bigger number take away the smaller number gives me 8. Now the range of these two would be, if I can spell range properly, sorry. The range of these two would be 14 take away 0, which would be 14, so that's not it. 13 take away 1 is 12, so that's not it. So what other numbers do it? So we could have 12 and 2, but that's obviously 10, so that's not it either. We could do 11 and 3, and I think that does it, doesn't it? 11 take away 3 is 8. That's my pair. So my numbers are 11 and 3. Okay, next one. It says calculate the size of the angle X, hence give the bearing of the point B from A. Now, first of all, let's just worry about the first statement. Let's calculate the size of angle X. So angle X, I can see I've got a triangle, and inside the triangle we should know is 180 degrees. That square means that's 90 degrees. So what I can do now is add together 90 and 50, which gives me 140, and then do the 180 inside the triangle, take away the 140, and I get 0, 40, so 40 degrees. So X is equal to 40 degrees. Now this word here, bearing, in terms of doing bearings, you need to know three things straight away about them, okay? So the three things are, they are always in three figures, or three digits, always measured from north, and that you always go clockwise. So in terms of measuring the bearing of point B from A, B is this line here. So if I just come and draw there from A, where B is, and I measure from north, it wants me to know what is all of this angle here. Well, I know that angle is 90. I know X now, so I just worked out it's 40. So 90 plus 40 gives me 130, and that's got 1, 2, 3 digits, so that would be my bearing, 130. Okay then, over the page, question 6. It says, a group of pupils is asked whether they can speak Welsh, French, both languages, or neither language. Their answers are shown in the Venn diagram below. The universal set, and then it gives that symbol there, that's just the definition of what the universal set is, all the numbers, contains all the pupils in the group. So this one here, that's representing someone who can speak neither Welsh or French. This 3 represents people who can speak Welsh and French, because it's in both circles. This 8, although it's in the Welsh, it's not in the French. These 8 people can only speak Welsh, and these 2 can only speak French. It says how many pupils cannot speak French. So that's all the people, all the numbers outside of this circle here. So that's 8 and 1. So 8 and 1, which is 9 pupils, okay? One pupil from the group is chosen at random. What is the probability this pupil can speak both Welsh and French? So that's 3 pupils, out of, well, we've got 8 and 2, which is 10, 3 and 1, which is 4, so 3 out of 40. Over the page, number 7. It says, find the whole number which satisfies all of the conditions. It is a whole number between 1 and 40 inclusive. Now that means inclusive means including, so it could be 1, 2, all the way up to 39 and 40. So 1 and 40 are both included, so it could be either of those, okay? So not all the other numbers not including them, okay? It said exclusive if it means that it wasn't including 1 and 40. The number is a multiple of 4, but not a multiple of 8. The number, or 3, is a factor of this number. The number is a square number, okay? Now, what I'm going to do is start working through all of these things. Start off with the square numbers, because there's far fewer of those. Factors of 3 means that 3 would go into the number, okay? So we're going to have a look at the square numbers that 3 goes into. So there's going to be certain square numbers that we can ignore straight away. We also know it's a multiple of 4, but not a multiple of 8. So in terms of that, we know that it's not in the 8 times table, but it is in the 4 times table. So what I'm going to do is start off writing my square numbers. And my square numbers are 1 times 1, 2 times 2, 3 times 3, and so on. And I'm going to go up until 36, because the next one would be 49, and that would be too much. Okay. Now, first of all, 3 is a factor of this number. Well, 1 only has one factor, 1, which is itself. So it's definitely not 1, so I'm going to discard that. Now, 3 doesn't go into 4, so I can discard 4 as well. 9, 3 does go into. 16, 3 doesn't go into. 25, 3 doesn't go into. So I'm only left with 2 numbers now straight away. And I might just say as 3 is not a factor. We're then told the number is a multiple of 4, but not a multiple of 8. So multiples of 4. The 4 times table would be 4, 8, 12, 16, 20. I'm going to go up to 40. So 24, 28, 32, 36. Now I can quite clearly see 9 is not in there, so I might just go and cross that out in a different colour. Not in 4 times table. So that only leaves us with one option then. It must be 36, and I can see that's in both lists. So the number must be 36. Okay? over the page. What is the total mass of 534 grams when it's added to 3.5 kilograms? Now the problem here is that's in grams, that's in kilograms. You need to know, to do this question, that 1,000 grams is equal to 1 kilogram. Now, these answers are both in kilograms and in grams, so it doesn't really matter which way we do this. What I'm going to do is change this into grams. So I'm going to write that as 3,000, so if 1,000 grams is 1 kilogram, then 3.5 kilograms must be 3,500 grams, and then I'm going to add on the 534, being very careful to ensure that I keep my place value nice and neat. 0 add 4 is 4, 0 add 3, 3, 5 and 5 is 10, so carry 1, 1 add the 3 there is 4,034 grams. Now, I can see there's 4.034 there, but that's grams. Well, that's definitely not the answer because that's way too small. It's 4,000. And I can see that answer's there not available for any of the others. Okay. However, this one here is given in kilograms, so it must be that one there. By dividing that back by 1,000 will give me that 4.034, but in kilograms, not in grams, which is why I didn't choose that one. The next one looks like it's a very similar question. It says, what is the total length of 35 centimetres when it is added to 7.8 metres? You need to know that 100 centimetres is equal to 1 metre. So I'm going to times the 7.8 metres by 100 to get 780 centimetres and add on the 35 centimetres. 0 add 5, 8 add 3, 11, carry the 1, 8. So the answer is 815 centimetres or 8.15 metres. So I can see this time they've given me both of those, that again is none of those. So it's one of these ones here. It's the 815 centimetres, not metres. It's this one. Or the last one's a real sneaky one, okay? How many millimetre cubes are there in centimetres cubed, okay? Now, one thing that I want you to be aware of, you should know that 1 centimetre is the same as 10 millimetres, okay? Looking at your ruler, you'll probably have on your ruler centimetres and millimetres on each side. So you'd be forgiven for saying, oh, well, 4 times by 10 then in that case must be 40, and that's one of the answers there. But what I'm going to do is just get an area here that measures 1 centimetre by 1 centimetre. So the area of that square is 1 centimetre squared, okay? Now, we actually haven't, I've even got this wrong. We're supposed to be doing volume here, so I need to go again. So that's going to be a cube, which measures 1 centimetre there as well. So it would be 1 centimetre cubed is the volume of that. Now, I'm going to have exactly the same cube. I know it looks a little bit bigger, but it's not. It's exactly the same. And this time I'm going to measure it in millimetres. So that would be 10 millimetres by 10 millimetres by 10 millimetres. And the volume of this would be 10 times 10 times 10, which would be 1,000 millimetres cubed. Okay? Now, that cube is that cube. They are the same. I've just measured the sides in a different measure. So I can make the statement that 1 centimetre cubed is equal to 1,000 millimetres cubed. Okay, so it's actually much, much, much bigger than you would assume from this, what is called just a line scale factor, okay, because we're timesing by 3 of them, we end up doing by the scale factor cubed, okay. So if I've got 4 centimetres cubed, then I've times that by 4, which means I must times this by 4 to get the 4,000 millimetres cubed there, okay? Number 9. Express 60 out of 300 as a percentage. So first of all, I'm going to write it as a fraction. 60 over 300. Now I can see that there is 0 on the top and bottom, so I'm going to divide the top and bottom by... actually, no, I was about to say it's 6 over 30, but that would be a really silly way to go with this. I basically want to turn that into being out of 100, because percentage means out of 100. So actually, instead of doing that, I'm going to rewrite my work here and say 60 out of 300 is equal to what over 100? Well, what do I do to 300 to make it 100? Divide by 3. Whatever I do to the bottom, do to the top. How many 3's go into 6? 2. So how many 3's go into 60? It must be 20. That's 20 out of 100, so that would be 20%. Okay, so definitely simplifying a fraction was not the quickest way around this. The next question says, some people were asked a question. 40% of the people said yes. A sketch of the pie chart is showing this information is shown below. Calculate the size of the angle X. Now, we're very, very importantly told that this diagram is not drawn to scale. So put your protractors away, okay? You can't use them, okay? Now, it's all around how many degrees we know would be in the entire circle. We know that 360 degrees is in a circle. Well, we know that 40% of that 360 degrees are people who said yes. So what I want to do is find 10%, which is the easiest percent to find. So you just do what it says on the tin. You divide by 10, so that would be 36. I'm now going to double the 10%, so double of 36. If I needed to, I could partition it to 30 and 6. Double each, so 60 and 12 to get 72. So 20% must be 72. So 40% must be double of that, which would be 144 degrees. Okay, next question. Now, if you're reading it carefully, you'll see that already up here that we are going to be assessed on the quality of our accuracy, communication and organisation in our writing. Don't worry about that for now. Look at this question here. 4 marks and 2 marks to the OCW, so 4 for the maths. That's still the main bit here, okay? Now, what I would recommend, before we go any further, to start trying to get those OCWs, make sure that you're putting your units in throughout your working. Any thinking you're doing, just share it. Write it down on your page, little arrow to it, and describe what it is. This does not need to be a massive essay. That's not what we're looking for, okay? The diagram below shows a rectangle and a trapezium. Trapezium we've been told on the second page, okay? So on page 2, you were told that the area of the trapezium is equal to a half a plus b, the parallel sides, times by the height. Okay, so we need to know how to use that formula rather than knowing it from memory. I do know it from memory, but it is on the second page, okay? Then we're told that AF is equal to 7. Now, all of this stuff has been put into the diagram. ED is 8, and the perpendicular distance between FC and ED is 6. So that thing there would be what we call the height here, okay? It then says calculate the area of the trapezium CDEF. Now, in order to do the trapezium, we need to know what A and B are, and A and B are the parallel sides, okay? Now, we also need to know what the height is, and we know there that the height is 6. So we've actually got A, we've got H, but we haven't got B. Well, what's this thing doing here? That must be starting to help me work that out. Now, I'm told that 7 times something is 91. That's the formula to work out the area of a rectangle. Now, I don't know what that something is, but I can find it out from what we've just said. Okay, 7 times something is 91. So I'm going to say area rectangle is equal to base times height. Okay, well that's 91. That base I don't know, and the height I know is 7. So in order to work out what the base is, I need to divide both sides by 7. Okay, now I don't know my 7 times table up to 91. I just know it up to 84, which is 12 times 7. Now I could work it out from there by adding 7 onto that and seeing how many times I add 7 to get to that number. Or I could come and work out here how many 7s go into 91 by doing the bus stop division method. 7s into 9, I can count once and I'd have a remainder of 2. 7s into 21 is 3. So this tells you that B, the base, must be 13 centimetres. Notice that I've gone and put in the units straight away. Nice and clear. What am I doing there? I'll just come and say here, I'll say finding missing length of rectangle, which is also the trapezium base. That's what I'm doing, okay? So I'm just explaining that. So I now know that this 7 times by 13 centimetres there, because it's a rectangle, that must also be 13 centimetres. I can now say area of trapezium is equal to a half A plus B H. Okay, I'm told that in the exam, okay, and that's that formula I've written there from page 2. Well, I can now say that is a half of the parallel side, so 8 plus 13, and then times by 6. Okay, now there's two ways of doing this. BIDMAS would be a good way to go through. 8 plus 13 is 21. So I want to find half of 21, and then I want to times it by 6. Now, option 1. What's half of 21? 10.5. 10.5 times 6. Go and work it out that way. Okay? But multiplying is commutative. And what I mean by that is that if I multiply 2 times 3, I get 6. And if I multiply 3 times 2, I also get 6. I can do it in any order. It doesn't matter. Those numbers I just made up. Okay? So rather than finding half of 21, why don't I go and find half of 6? Half of 6 will be, because 6 is an even number, will be a nice number. So I'm going to do half of 6, which is 3, and then I'm going to multiply it by 21. 3 times by 21, 21, 42, 63. So my final answer would be area trapezium, just because I've run out of room, is equal to 63 centimetres squared. Okay? And as far as I'm concerned, that would be enough to have everything that I need. I've consistently used units throughout. I've explained what I'm doing here. I've gone and shown all of my working. I've gone and said here, rather than saying I've done this because I can do it in any order, I don't need to do that because I've just said 3 is obvious what I've done there, okay? And then finally I've given my answer for area of trapezium. Okay then, next question. 200 young people are taking part of a conference held in Aberystwyth. One of the young people is chosen at random to be the chairperson. Complete the table below to find the probability that the chairperson lives outside the United Kingdom. Now, what we need to know here is that all of these numbers must add to 1. Okay, that's one of the definitions of probabilities. Now, 0.2 and 0.3 is 0.5. Add the 0.25 is 0.75, and add the 0.15 would be 0.9. So what I'm going to do is just show that, so anyone looking at my work can see that I'm doing that maths, because if I have gone wrong anywhere, I'll get a method mark for showing that I know what I'm doing. So I made that 0.9, so 1 take away the 0.9 is 0.1. Okay, so if I check going the other way, it should work. 0.1 adds 0.15, 0.25, add 0.25 is 0.5, 0.8, 1. Perfect. Okay. How many people, or how many of the 200 young people live in mid Wales? So what we look for is mid Wales and its probability, and there's 200. Okay. So what we need to know then is to work out the number is that we would do the probability multiplied by the probability times by, what am I looking for here? So mid Wales would equal the probability times by the total. Okay, so the probability is 0.3, and then I want to times that by 200 young people. Now there's quite a nice way of splitting that up. I'm actually going to times this by 100, because times it by 100 is very easy to do, and then I'll times that by 2, because 100 times 2 is 200, okay? Goes back to what I was saying before about multiplying being commutative, can be done in any order. 0.3 times by 100 is 30, then timesing that by 2 gives me 60. Next page, it says, describe the single transformation that transforms triangle A onto triangle B. The first word you should be looking at that is most important is transformation. There are 4 transformations. There is reflection, i.e. so it looks like it's looking back at itself. There is rotation, i.e. it's been spun around. There is enlargement, i.e. it's got bigger, or it could get smaller. If I make something half as big, then it's actually going to get smaller. And then number 4, the one that often gets forgotten, is translation. That I've literally just picked it up and moved it somewhere else. It hasn't changed at all. But I can see that's not the case here. So is this triangle A, is it still pointing the same way? Does it still look exactly the same? No. Well, it's not translation then. Has it got any bigger? No. Has it been spun around? Well, not really. It's not been spun around. It's not like it's upside down the other side now. It's not been spun around. It looks to me like it's looking back at itself, and that's what we call reflection. Okay, when you see a reflection of yourself in the mirror, you're looking back at yourself. So, in order to work that out, I need to find out where that line of reflection is. So I'm going to put my ruler there, and I can see that this dotted line here that I'm drawing must be what we call the mirror line. Okay, mirror line. Now, in order to get the full 2 marks here, we're going to say it is a reflection. That will get us 1 mark. But I will need to say how. Where is it being reflected? Well, it's being reflected in this line. And that line goes through the x-axis at a value of -2. So we need to say reflection in x equals -2. Over the page, translate. Translate the triangle using column vector 5 minus 6. Now a translation, I've already covered, is exactly the same. I'm going to pick that up sort of like at the fairground when you have those sort of like grabbers where you move it up, down, go in and plonk and it comes back, okay? I'm going to pick that up and do 5 minus 6 to it, which we'll come to in a second, and then that'll plonk it somewhere else, let's say there, okay? Now, this will be alphabetical. So 5 is x, y is -6. Now, if it's 5, it really means it's +5. So pick any corner. I picked the top one. I want to add 5 in the x direction. So I'm on -6, I want to add 5. 1, 2, 3, 4, 5. There. I then want to take away 6. That means I want to go down 6 places. 1, 2, 3, 4, 5, 6. That new top corner is going to be there. Now I could repeat that with every single corner or every single vertex. I could say here, go across, 1, 2, 3, 4, 5. Now I go down 6. 1, 2, 3, 4, 5, 6. It's there. But what I tend to do is to say, well, if I've got that top corner, I know that height is 2, so it's got to be 2 in my translation. And you see the base is 1, 2, 3, 4 squares. Then this must be 1, 2, 3, 4 squares here. Okay? So I'm going to just pop that there, and then I'm going to just draw in the shape. Write down the column vector that will reverse the translation in part 1. Well, if I've just added 5, then taken away 6, I need to do the exact opposite of that. So I need to take away 5 and add 6. I could write +6, or I could just say it is -5, 6, like they told me there. And I said, oh, I've got to go and put the plus in. Either of those are fine. They're both correct. Okay? Number 14. The exterior angle of a regular polygon is 36 degrees. How many sides does the polygon have? Well, first of all, let's get our heads around a couple of things here. Polygon just means a many-sided shape. So it could be a triangle with 3 sides. It could be a quadrilateral with 4 sides. It could be a pentagon with 5, and so on. Exterior angles. You should know that all exteriors, no matter how many sides the shape has got, exterior angles always add to 360 no matter what. Okay? Now, if I come and have a look at a couple of shapes here. This is a triangle. Inside it is 180. The exterior angles are found by continuing the line here and going around the shape, around, like this. So it'd be these 3 angles here going around the shape. Hence, we've gone around the shape in a circular motion, hence why it's 360. Okay? Now notice with a triangle, 3 sides, 3 angles, 3 exterior angles. So in this case, if it was this triangle, I would do 360, which is all of the exterior angles, divided by the number of angles, which is the number of sides, and I find out they're all 120. And that's if it's regular. That's the other word we haven't covered. Regular means all angles, all sides are the same. Okay? So, I know that if I do 360 degrees divided by the number of sides, or the number of angles, they're the same thing, I get an angle. I'll find out what a single angle is. Well, I actually know what the single angle is 36. So rather than writing the angle, I could write in 36 degrees. Well, 360 divided by what is 36? Well, the number of sides must be 10. If I can write 10, must be 10, because 360 divided by 10 is 36. Calculate the sum of all the interior angles of this regular polygon. Okay, so I know that there are 10 sides, so number of sides up here is 10. To calculate the interior angles. Now, there's 2 ways of doing this. Option number 1 is what we've just worked with. We've got an exterior angle of 36 degrees, so that looks 36 degrees there. Well, I can go and work this angle out very easily by doing angles on a straight line, because I've extended the line to find the exterior, and find out this angle must be 180 take away 36, which would be 4, 4, 1, which would be 144. Okay. Now that's the interior, that's the inside. And this is the exterior, the outside. Okay? Well, I already know there's 10 sides, and if there's 10 sides, there must be 10 angles as well. So it would just be 144 times by 10, which will give me 1,440 degrees as the total sum of all of the 10 angles. Okay? There is a slightly different method that you can use, which is using a formula as follows: 180 times by n minus 2. That's a formula that you would have been taught in school. You shouldn't just know it, well, you should know it off the top of your head if you've been taught it in school, but if you haven't, the exterior angles is probably a nicer way to go around it. And you would have then done 10, the number of sides, take away 2, so you'd have done 180 times by 8, which will give you exactly the same answer over there. Next question, number 14. It says, write down the first 3 terms of the sequence whose nth term is given by n squared minus 6. Well, to find the first term, we're going to do sub n for 1. So we're going to square 1, and then we're going to take away 6. 1 squared is 1. 1 take away 6 is minus 5. To find the second term, we just sub in 2. 2 squared is 4. 4 take away 6 is minus 2. And then to find the third term, you've guessed it, we're subbing in 3. 3 squared take away 6 is 9 take away 6, which is 3. Okay? It then says, write down an expression for the nth term of the following sequence. So the first thing we do is check what the jump's going up in. Now I can see that 5 to 11 is a jump of 6, jump of 6, jump of 6. Because this is going up in 6's, this is the 6 times table, and we call that 6n. To then find out how it differs from the 6 times table, we could either write the 6 times table above, so 6, 12, 18, 24. What do I do to 6 to get to 5? Take away 1, 12, to 11, take away 1, take away 1, take away 1. It's 6n, take away 1. But another way you can find it is by working out what number must be here. What adds 6 is 5. In other words, what's 5 take away 6? Well, that must be minus 1. That number there is that number there also, okay? Whichever way you find easiest. Number 15. Circle the correct answer for the following. 3 cubed, 9 cubed, 9 to the power 4, 18 squared, 3 to the power 4. Right, some of these answers are easy, some of them are hard, okay? I don't want to go anywhere near 18 squared. I don't want to go anywhere near 9 to the power 4, okay? Because they're big base numbers. And in this case, the power is quite big. I don't want to do that either, okay? First of all, let's work with the smaller ones and see if it's those to begin with. 3 cubed means 3 times 3 times 3. Well, that's 9 times 3, and 9 times 3 is 27, so it's not that. Let's go and work out 3 to the power 4. Well, that would be 3 cubed, 3 times 3 times 3, then times by 3 again. We've just worked that out. That's 27. What's 27 times 3? Don't know. 27 times by 3. 7 times 3 is 21. 2 times 3 is 6. Add the 2 is 8. It's 81. That's it. It's 3 to the power 4. It's this one. Okay? So I'll just go and put a line through those ones there. Okay? 9 to the power 4, for example, would be 9 times 9, which is 81, then times that by 9, which is I don't know, and then times that answer again by 9, hence why I don't want to go anywhere near it. 2 to the power 5. No, sorry, 2.1 to the power 5. Right, okay, so let's start trying to work this out. First of all, let's work out what 2 to the power 5 is, and we'll start working off that. 2 to the power 5 means 2 times 2 times 2 times 2 times 2. 2 times 2 is 4. 4 times 2 is 8, 16, 32. So 2 to the power of 5 is 32. So you're probably drawn to that answer straight away. But let's just start eliminating some answers we know it can't be. There's no way it can be that answer. There's no way it can be that answer because they're smaller than 32. And this number is smaller than 2.1. So 2.1 to the power of 5 will be bigger again. Okay? Now, it could be either of these three here. Now what I'm going to do, it's a little bit of extra work down here. 2.1 to the power of 5 would be 2.1 times 2.1 times 2.1 times 2.1 times 2.1. So I can see why someone might say it's 32.1. I can also see why someone might say it's 32.5. Okay, so both those answers are logical. I can see that from that, why we're getting there. But let's start focusing on what 2.1 squared is. 2.1 times by 2.1. Well, I'm going to partition this into 2.01, sorry, 2 and 0.1 and 2 and 0.1 and times those together. 2 times 2 is 4, 2 times 0.2, sorry, 2 times 0.1 is 0.2, 0.2, and this would be 0.01, okay? Now, adding those together, I'm going to get 4.41. And that's because I've times two decimals together, you end up starting to go really far into the decimals. So you can see I'm already on two decimals there. If I times this by 2.1 again now, I'd be doing 4 and 0.4 and 0.01 and then 2 and 0.1. I'm just going to start generating more and more decimals. 0.1, for instance, times by 0.01 would be 0.001. Well, that's going to be a massive, massive decimals, which neither of those have. It can't be either of those. It must be that. Okay, so that's the sort of process we're looking for to do that question quickly. This one here is expecting you to be able to know something, to know what the power of a half means. Okay, so you'll either know this or you won't. If it says the power of a half, it means the square root. Okay, so what is the square root of 12.96? Well, I've got absolutely no idea. But what I do know is that the square root of 9, so I'm looking at my square numbers, is 3. And the square root of 16 is 4. Well, why have I chosen those? Well, that's the square number below 12.96 and that's the square number above 12.96. So I know that the answer must be between 3 and 4. So it isn't 2.16. It isn't 4.32 because that's above 16 to get that answer. It could be 3.6. It could be 3.3. It can't be 6.48. Okay, they expect you to halve that. That's not what this is doing. So which one is it? Well, let's go and work it out by doing 3.3 times by 3.3, which I'm wishing I'd give myself a little bit more space for. So I'm going to do 3 and 0.3, 3 and 0.3, and work out what this is. 3 times 3 is 12. Sorry, 3 times 3 is 9. I wrote the right thing. 3 times 0.3 would be 0.9, 0.9 again, and then 0.09. So that's going to be 1.8, so 9 plus 1.8, and then 0.09. Well, I can tell you it's not going to make 12.96 already. So 9, 8, 10 is 10.89, okay? But there's no reason why I couldn't have just stopped there and said, well, it's obviously not going to be that answer, so therefore it must be this answer here. Okay, so it's not that one either. Okay then, over the page. Oh, so we've got a bit of loci here, so you're going to need your compass for this, okay? It says, using only a ruler and a pair of compasses. A pair of compasses is this thing here, okay? It's a pointy thing with a pencil on it. Construct a triangle so that it satisfies PQR is 60 degrees. So that means the middle letter, Q, must be 60. So it's this that must be 60. Okay, you didn't see what I did then, did you? It's off the screen. All I've done is highlight it down here. Okay? And PQ is 7. Okay. Now, I can't use a protractor. It doesn't say to use a protractor, so I've got to use my compass. Now, in order to do this, this is really asking you to know how to draw this type of triangle here, an equilateral triangle. An equilateral triangle has equal angles, all of 60 degrees. Okay, so it means that the sides must all be the same. So what I'm going to do here, I'm going to measure that line there. They've drawn that one for me, okay? Now, what I'm going to do is open my compass to the same length as that line. Now there isn't, I could do it at a smaller distance if I wanted to, but I'm going to do it at this one, okay? Now, I always find it easiest to actually move my paper. Let me make sure you can see this properly, sorry guys. I'll try popping that there. I always find it easier to move the paper rather than holding the top of the compass. So what I'm going to do is just move my paper to make an arc there. Okay? I'm now going to move the compass without changing the width so that it's the same line there. Okay? Now where these two lines cross, this point here, I'm going to go and draw that line up to there, to Q. Now, the reason why I'm doing that is because if I did draw that in as well, that would make an equilateral triangle, therefore this must be 60 degrees. Okay, which again, sorry, you can't see what I'm writing. I'm just saying 60 degrees there. Okay, we're then told that P to Q, which P isn't drawn, P's up here somewhere, is 7 centimetres in length. Now, this won't be 7, okay? This line is the same length as that line, and when I measure that earlier, that is 8.5, okay? So if I just come over here and make a mark at 7 here, there, making sure that I'm really accurate, it's dead on the 7, and then making it here, I'm going to just come and draw that line now to go and finish off the triangle there. Okay? And make it really obvious that this is my answer, that this is P. And I'm just going to scribble that out there I did that to make things easier to go and draw my 60 degrees, okay? So I've now drawn accurately that triangle. Part B, using only a ruler and a pair of compasses again, construct a line from A that is perpendicular, so it's expecting you to know what that means, perpendicular to the line LM. So LM is this line here. Now this one's a fussy one. It's just going through a set of instructions that you need to remember, okay? Now in order to do this, perpendicular means at right angles. That word perpendicular means at right angles. You go and get your compass on A and you open to it so it can draw an arc that is going to cross that line in at least 2 places, okay, or in only 2 places. So again, I'm going to do that by moving my sheet there, okay. Now, what's that has happened? It means where they have crossed here and here, that is going to be in the midpoint of it, and it will then create an angle of 90 degrees. So what I'm going to do now at these 2 points here is I'm going to keep the compass at the same length, and I'm going to draw an arc from here. You'll notice it goes through A. That's not a coincidence. It should have happened. And then I'm going to come over to here and draw another one there, another arc. And where these have crossed, on this arc here, and here where it's gone through A, I'm going to draw a line. Okay, now what that's done is it's created this length of line, so that's in the middle of it, and I've bisected that line. Okay, and that also creates an angle of 90 degrees. Okay, question 18. It says, Dylan is having a weekend in Wrexham. The probability that he'll be visiting the gardens is 0.7. The probability that he's going to this place, going to this heritage centre, is independent. Now that means it is unaffected, okay? So if he's gone to one place, it doesn't mean that he's going to say, oh, I've already been to one place, I'm not going somewhere else, okay? So that means it's unaffected, okay? The probability that he goes to the gardens and the heritage centre, they're loving this question, it's come up quite a lot recently, is 0.28. Now what people can usually do is say, oh, the branches must add up to 1. Okay, he's either going to go to the place or he's not going to go to the place. Well, he's going to do one of those 2 things. So all probabilities add up to 1. And then what people do is they say, oh, the heritage centre, yeah, 0.28, so that's 0.28 both sides. But it's not telling you that. It's telling you that you go to the gardens, and it even has it in bold, and here is 0.28. So that's this option here. This is 0.28. If he does both of them, it's 0.28. That means this number we always multiply between branches, times by this number must be 0.28. So 0.7 times what? I'll just say x is 0.28. I always just say, well, what number times by that must be that. So for me, that's going to be 0.4 because 7 times 4 make 28. So 0.7 times by 0.4 must make 0.28. You'll find more often than not that these are just single digits on these branches. It'll make your life an awful lot easier. Because they're independent, they're unaffected, so I can write in the same probabilities here. Okay? So 4 marks for doing all of that maths. Calculate the probability that Dylan goes to the gardens but does not go to the heritage centres. So, go to gardens and we do not go to the heritage centre, so that's there and there. That's 0.7 multiplied by 0.6. So 0.7 times by 0.6 is 0.42. And then over the page, and I believe this is nearly the last question, we've got 3 more to go. Now these have been taken out in recent years of study due to the COVID pandemic. However, I will go through them, okay? Now these are potentially quite fussy questions, okay? Now what I do is I just change what all these things are, okay? W will be width. Width is a length in general. Radius would be r, that's a length as well, and d is also a length. That would probably be a diameter, okay? What we're going to do is change each of them to L. So we're going to have L cubed plus L squared times by L. Well, L squared times by L would be L cubed. L cubed add L cubed would give me something L cubed, okay? I don't care that it's 2L cubed, it's just that it's going to be something cubed. So this must be a volume, okay? Now it seems weird when you first do it, we'll do a few more, okay? 3W, so 3 lengths add 2 lengths add a length. Well, that's just going to give me 6L, or just L in general, something else, so that would just be a length because it's not squared and it's not cubed. This one here will give me L, L, L. That means L times L times L, so L cubed plus 5L cubed. Well, that's going to be L cubed plus L cubed, so that's also going to be a volume. This one here would be 4L plus pi, which is just a number, and then an L squared, okay? Now, this is the first one that's come up. We've got a length, add an area. That's not going to work. That's none of them, okay? It's a nonsense. And then this one here is going to be L times L times L, so L cubed, L times L times L divided by L. So initially it's going to be an L cubed divided by a length, which will give me L squared. So this must be an area, okay? Number 19, it says factorise x squared plus 4x minus 21. Now this is effectively getting you to use your problem solving skills as saying that the number at the end must multiply to be 21 and the number in the middle must add to 4. And what do I talk about numbers? It's a pair of numbers, okay? So initially to factorise this, see it's x squared at the front, x is going in both. You're now thinking of a pair of numbers that times together to give minus 21. Well, going back to what we looked at the very start of the paper, plus times by plus makes plus, plus times by a minus, and so on. Well, then if I'm timesing to get a negative, I must have one of each sign. So it must be a plus and must be a minus. So I now want to think of pairs of numbers that times together to make 21. So that's 1 and 21, 3 and 7, and that's it. Now, if I go and put in the 1 and 21 there, it'd be plus 1 minus 21. That would make minus 20. It's definitely not that. I'm supposed to make plus 4. If I went and switched it round, it would just make it the other way around. It would make it plus 20. If I made it 3 and minus 7, plus 3 minus 7, that would make minus 4. So it must be that the 7 is positive and that the 3 is negative. Plus 7 take away 3 is plus 4. Plus 7 times 3 is minus 21. Okay? Now, from here, it then says go and solve that equal to 0. And it's the factorising that helps you go and solve this. Now, these two brackets are touching. So that means this times by this must be 0. So that either means, for two things to times by each other and the given answer is 0, it means that either this bracket on the left is 0, or it means this bracket on the right is 0. So for instance, let me just try and explain that in a little bit more detail. Think of any number in the world. Think of any number in the world. Doesn't matter what you're thinking of, what time of the day it is, what time of the year it is, whenever you're watching this. Whatever your number is that you're thinking of, if you times it by my number, our answer is 0. I promise it is. That's because I'm thinking of 0. So these two things here, either that thing is equal to 0 or that thing is equal to 0. So what I'm going to do now is just get x by itself by taking 7 off both sides, and I get x equals minus 7. And then here I'm going to add 3 to both sides to get x equals 3. And if you sub those into that, it should equal 0, okay? And it will. Next question here, it says solve the equation 2x minus 3 over 5 plus 4x plus 5 over 2 equals 11 over 2. There's a couple of different ways to solve this. My favourite way of solving it is to go and find the lowest common multiple of the denominators, okay? What is the smallest number that they both go into, okay? So the LCM would be equal to 10. 5 and 2 both go into 10. And what I'm going to do is times every single bit of the equation by 10. Why can I do that? Well, let's just have a look at these numbers here. 3 add 2 is 5. Agreed? Okay, times every bit by 10. 30 add 20 equals 50. Is it still true? Yes, it's still true. So as long as you times every single bit by the same number, you can absolutely go and do that. That's still equal. So we're going to get 10 bracket 2x minus 3 all divided by 5 plus 4 bracket, no, plus 10, sorry, 4x plus 5, 4x plus 5 over 2 equals 10 bracket 11 over 2. Okay, so every bit times by 10. I'm now going to cancel down how many times the denominator goes into that multiplier there. How many times does 5 go into 10? Twice. How many times does 2 go into 10? 5 times. 2 into 10, 5 times. Now we've got no denominators, this equation becomes a million times easier to solve. 2 times by 2x is 4x minus 6. 5 times by 4x is plus 20x plus 25. 5 times by 11 is 55. Collect your x's. 4x, add 20x is 24x. Minus 6, add 25, think of it the other way around. 25 take away 6 is plus 19. That equals 55. Take 19 away from each side. So 24x is equal to 55 take away 19, 5 take away 9 is 6, 4 take away 1 is 3, and now divide both sides by the number that's multiplying by x, so 24. So I can write 36 over 24 initially, and then what I might do, in fact actually that's solved. Okay, it says solve the equation, it didn't say put it into lowest terms, but it does cancel down quite nicely. 12 goes into both, so it's 3 over 2, which is 1.5, but all of those answers are correct. We solved it, so you should get the full marks just for writing that answer there. Okay, on to, I think it's the last question now. Yes, nothing after this one, so well done. We've made it through, and hopefully in just under an hour. A cuboid measures 40 millimeters by 25 millimeters by 12. Now the key thing that they've then said here, and they sometimes put it in bold and sometimes not, correct the nearest millimeter. Okay, if it's correct the nearest millimeter, that means it's correct the nearest 1 millimeter, and we're going to be doing something called upper and lower bounds. So we're going to halve that number to get 0.5 millimeters. And we are going to start finding the upper and the lower bounds of all of these numbers, okay? Now, I'm going to write a table. They've not left me much space here, okay? So I'm going to write down here 40 millimeters, 25 millimeters, and 12 millimeters. I'm then going to write here lower bound, upper bound. Well, if they are rounded to the nearest millimetre, then 40 could have really been as low as 39.5. And it could have been as high as, now we just say 40.5. Now obviously that would round up, so we recognise we can actually never quite get to the upper bound, but it makes this calculation very, very simple and easy to do. Just take off 0.5, add 0.5 on. Then to get this length here, it must be 24.5 and 25.5. This one here, 11.5, 12.5, because all of the measurements are correct in the nearest millimetre. It then says calculate the greatest length possible of A. Well, A is this length here. That's this length here, and they want the greatest, so plain and simple, must be 40.5. It then says, what is the greatest possible value of B? Well, B is 2 of those blocks, so it's going to be 1, 2 of those. Well, if I want the greatest, then it's going to be that, then that again. So it's going to be 25.5, add 25.5. 5 add 5 is 10, 10 again, 11 add the 1, and then 5 here. So my answer is 51 millimetres. Millimetres up there as well. What is the least possible value of C? Well, C is 2 of the heights, so it's going to be 2 of those. And the least would be the lower bound. So it's going to be 11.5 doubled. So 11.5, add 11.5 is 10. Carry the 1, 1, 2, 3. No carry the 1 this time because there is no 1 to carry. 1 add 1 is 2. So my answer is 23 millimetres. Okay, hopefully that was really, really useful. I'm glad that you're able to tune in and watch this. If you could hit the subscribe button, that would massively help me out, as I'm trying to continue to make these videos for free. And if you want any tutoring, please feel free to go and visit my website. I do online courses as well as face-to-face tutoring in Cardiff, if that is where you're based. Thank you very much for watching.